Yuri Bondarenko from the Russia Institute of Applied Astronomy of the Russian Academy of Science, who is reporting about the radar observations of cold Centaur rock from 1966.
I present the radar astronomy group in Institute of Applied Astronomy. So we study near Earth objects and moon using methods of radar astronomy. So today I would like to present the results of our work on radar observation of one unusual near Earth object. So this object has been discovered on September 17, 2020 with the Pan-STARRS 1 telescope on Hawaii. So assumed to be an asteroid orbiting the Sun, the object was given a standard designation 2020 SO by the Minor Planet Centaur. So this object made two large eccentric orbits around the Earth-Moon system between November and March. And during this interval, the object twice approached the Earth within 1 lunar distance on December 1st and on February 2nd. So this NASA animation shows the temporary orbit of 2020 SO around the Earth from November to March. But scientists at the Center of Near Earth Object Studies at NASA JPL suspected that it was not a normal asteroid because most asteroids' orbits are more elongated and tilted relative to Earth's orbit. But the orbit of 2020 SO around the Sun was very similar to the Earth. Then astronomers around the world made additional observations of 2020 SO and found that impact of solar radiation pressure to its trajectory became evident and confirmed that this object have low density. Suspicions that this object was a remnant of old space mission were made by director of Near Earth Object Center, Paul Schotters. He found that this object came close to Earth several times over the years, but the approach in 1966, according to his analysis, was close enough for it to come from the Earth. So then he checked the launch dates of lunar missions and find that it has a match with the Surveyor 2 mission. So the Surveyor 2 lunar lander was launched to the moon on September 20, 1966 on Atlas Centaur rocket. This mission was designed to investigate the lunar surface, but something goes wrong, and after separation from the booster, the spacecraft was lost, and the booster sailed past the moon and disappeared something in space. So the goals of our work was to obtain the physical properties of this near Earth object using radar astronomy in hope to understanding its natural object or old rocket body. Over past 20 years, at least 6 man-made objects have received asteroid designations. The ability to distinguish between natural and artificial objects is very important because countries increase their research in space and more objects are in orbit around the Sun. So radar observation of this object we carry out in cooperation with this asteroid radar research group from GPL. Our observation involved 70-meter DSS-14 antenna from Goldstone deep space complex, deep space communication complex, and our 32-meter radio telescope from Svetla Observatory. So we observe this object in static mode because it approached us on a very close distance. Our joint radar observation carried out on November 30, while this object was in visibility window of our two antennas at about 200,000 kilometers from Earth. So not far from its closest approach on December 1st. This table shows the observation master log. As can be seen from the table, the observations consisted of several series with different forms of transmitted signal. First was continuous wave signal we transmitted to clarify the ephemeris and approximate characteristics of the objects. Then we use modulated signal to resolve the object in Doppler frequency and time delay. So this figure shows the principle of bistatic radar observations. The radar signal emitted at the carrier frequency after reflection from the object received at a frequency shifted by the Doppler effect. Also, since the object rotating, the received echo will have a broadening because different parts of surface will have different relative velocities. Also, the circular polarization ratio of signal is reversed after the reflection from the surface, and the maximum power of the reflected signal will be in opposite to the transmitted polarization, but some part of signal due to secondary reflection received in the same circular polarization. So if we apply Fourier transform to the echo time series, we obtain the continuous wave echo power spectra, like on this picture. In this figure, we can see the echo power spectra in opposite and the same circular polarization recorded at the carrier frequency with Doppler shift and broaden it due to the rotation of the object. If we use a modulated carrier, we may cross-correlate it with echo with the transmitted code and obtain so-called range Doppler radar image. So this image consists with many echo power spectra at different time delays. And spatial resolution of such image will depend on selected modulation mode and duration of Fourier transform. In our case, the modulation mode have a spatial resolution about 90 meters, and this resolution did not allow the object to be resolved in range because its size less than 19 meters, and we discuss it some later. So here you may find the range Doppler radar images of 2020 SO object obtained at Svetla Observatory on November 30. So on this image, the range or delay distance from the observer increases down at 90 meter per pixel, and Doppler frequency increased to the right at 10 hertz per pixel. The entire object fits within one range pixel, which means that it's less than 90 meters. So from the obtained images, we estimate the Doppler broadening, which varies from 100 to 400 Hertz during object rotation phase. Doppler broadening as a function of time can be used to obtain the rotation period. So the images below are arranged in chronological order and corresponds to one of 4 object rotation phases, repeating with a period of 9.5 seconds. The integration time of each image is half second. The object diameter is a function of asteroid rotation period, Doppler broadening, radar wavelengths, and angle between observer's line of sight and object's apparent equator. So considering the rotation of 9.5 seconds and assuming the angle is 0, we relieved the object size varies from 3 to 10 meters. In the following picture here, you may see continuous wave echo power spectra of this object obtained in 1 minute integration time. Solid and dashed line denotes the echo power in opposite and same polarization. The obtained spectra we used to determine the circular polarization ratio and radar albedo. So by integrating these 2 spectra, we obtain the radar cross section, and from this we obtain the radial albedo of about 1, which confirms that surface of the objects has a high reflectivity in the radio range. Also, the ratio of integrated same and opposite echoes is a measure of near surface wavelength scale roughness. A higher ratio indicates a greater degree of near surface wavelength scale roughness or multiple scattering. We estimate the circular polarization ratio of about 0.4. This high ratio can be explained by the presence of many surface irregularities at decimeter scales. 1 day later, on December 1st, the results of photometric observation were obtained. Several optical observatories reported the rotation period of about, from photometric observation, of about 9.4 seconds, which is in good agreement with our radar results. An amplitude of about 2.5 magnitude suggests a 10:1 ratio between maximum and minimum dimensions of the object. As you can see from this animation, the object had the same bright flicker in the optical range. Also, December 1st, a team from Lunar and Planetary Laboratory of Arizona University performed the spectroscopy observation of 2020 SO using NASA infrared telescope on Hawaii, and they compared the obtained spectra with the spectra of another old Centaur rocket, which had been in geostationary orbit from 1971, and they obtained spectra are consistent with each other, thus finally concluding that this object is a Centaur rocket booster. And, summing up the results, the following conclusion. As a result of radar observation, the rotation period was determined to be only 9.5 seconds, which is too fast for asteroids. Obtained range Doppler radar images confirm that object has elongated shape with length about 10 meters and width about 3 meters, which corresponds to the size of Centaur upper stage. The radar albedo is about 1, confirms that surface has a high reflectivity in radio range, typical for metals, and high circular polarization ratio can be explained by presence of many surface irregularities at the symmetric scales. All our results consistent with observational data obtained in other ranges of spectra, and we demonstrated the ability of radar observation to distinguish between natural and artificial near-Earth objects. So, thank you for your attention.
Well, thanks a lot for the very interesting presentation. I think we have a question from Vladislav.
Thanks for very interesting talk. I have a question. So, as I understand correctly, it was unknown before observations, but is it asteroid or rocket? And you can prove it only by bistatic radar and optical measurements. And a second question, are you interested in some kind of VLBI, such kind of experiments? Because we're trying to also do some kind radar plus VLBI, but not really in contact with goldstone. So if you're interested, we can do something together.
So yeah, first question. Yes, this object is, then it was discovered in September. Nobody knows its nature, and only some points like its unusual orbit, like Earth-like orbit, tell about its artificial nature. And then several types of observation like infrared, optical, and radar make observation and found evidence that it's not asteroid. And about the cooperation, of course, we can make the joint observation with your observatory and find some interesting object for it.
Okay, thank you. So we will keep in touch with you after conference.
Okay.
Yeah, thank you.
Any other question for Yuri? I have one. Is such kind of monitoring based on, I mean, is regularly based or is ad hoc organized when there is an object, a strange object to be recognized? Which is the mechanism?
So the mechanism, such planetary radar like DSS-14 now only in goldstone, and they have the program of asteroid research, near Earth asteroids, and they have a schedule during the year with all potential hazardous asteroids, which the team in JPL observed using the goldstone radar. And sometimes several objects due to its large size or due to its close approach can be observed in our radio telescope in Russia. And and sometimes this object may be not the asteroids and artificial. And we participate in such observation during our cooperation with JPL.
Thanks a lot.
Thank you.